Hi, in this video I'll be teaching you about Newton's first and second law of motion. Before we begin, these are some terms that you need to know. First is net force, the vector sum of forces acting on a particle or body, and second, inertia, the tendency of objects to keep moving in a straight line at a constant speed when no forces act upon them. What did the first law state? The first law stated that if an object is stationary, it will not begin to move by itself. If an object is moving, its speed and direction will not change unless something makes it change. This is often referred to as the law of inertia. The formula of this first law would be sigma force equals to 0, or the net force on the motion is 0. I'll be illustrating to you how this is applied. For example, let's say there's a box, a candy box, placed on a horizontal surface with its initial positions at rest means there is no net force acting on an object, then the candy box will remain at rest. Next, here we have a candy box and two people trying to push the box, one on the left and one on the right. If the two people here exert the same amount of force, let's say 40 newtons on each side, then the forces are balanced, and thus the box will not move, it will stay at rest. Lastly, we have the same candy box and the two stickmen trying to push the box forward. If the box is moving at a constant speed of 4 meters per second, then it will keep on moving in the same direction and speed, unless there is an external forces acting on it. So now we're done with learning the theory of the first law. So let's do some questions of true or false to check if you're still on track. So the question is, the object will still come to rest because of its inertia when there is no net force acting on it, true or false? The answer is false. Why is that? It is because inertia is not a force, but the object's tendency to resist the change of velocity. Next question. An object that is not accelerating or decelerating must have no forces acting on it. Let's look at the answer. The answer is false because there might be more than one force acting on an object, and that force might be against motion, like friction force. So now we're done with Newton's first law of motion. Next is Newton's second law of motion. The important terms to know here is acceleration, which is the rate of change of the velocity of an object with respect to time. Okay, so what did the second law state? The second law stated that the force on an object is equal to the mass of that object times its acceleration, or the formula summation F equals to ma. Let's see the example of this. Okay, so here we have a horizontal surface, then there's a car, a person trying to push the car forward. Just as we know the formula that force equals to mass times acceleration, we can say that the person here is trying to exert the force on the car, which is the mass, to make the car accelerate forward. Let's see the two pictures here. For example, the scene on the left, the mass of the car is 35 kg, and on the right, the mass of the car is 300 kg. Which side do you think the person needs more force in order to accelerate the car? So it's obviously the second picture because the car is of more mass. Now let's do one question before we end our class today. The question said, Sophia, whose mass is 52 kg, experienced a net force of 1,800 Newton at the bottom of a roller coaster loop during her school's physics field trip to the local amusement park. Determine Sophia's acceleration at this location. Okay, so first what we have to do is to list what we know. So here we know the mass is 52 kg and the net force of 1,800 Newton. Then look for what the question wants. So here, the question wants the acceleration. So now we can use the formula F equals to ma to find for the acceleration. So after plugging in the variables, you will get the answer of 35 meters per second square. So this is the end of the video. Thank you for watching, and don't forget to like, subscribe, and stay tuned for new videos.